Okay, in our Goal 7.7, we are working with functions. This is a very, very, very brief kind of exposure to what functions are and what function notation looks like. If you do like Algebra 2, you would do it like a ton more with this. Very simple, just exposure about functions. First of all, some definitions that you don't need to memorize in terms of like regurgitating and writing them out for me, but in terms of directions, you'll need to know what I'm talking about, okay? A relation is simply just a set of ordered pairs, which I'll show you one of those in a second, okay? The domain is the set of all first coordinates, or from the ordered pairs, that's the x values. The range is the set of all second coordinates, that would be the y values. So domain and range, D comes before R, X comes before Y, so don't mix those up. Alphabetical, okay, just like the coordinate. A mapping diagram, which you're going to see in a second, very popular kind of standardized test questions using a mapping diagram, shows how the domain and range are paired, okay? A function is a relation in which each element of the domain is paired with exactly one element of the range. For you, this is what you probably should remember, because that's the easiest thing to remember, is that x can't repeat. X cannot repeat. We're going to answer yes or no, determining if something is a function, based on that definition. Okay? A vertical line test is a test used to determine if a graph is a function. If any one vertical line drawn through the graph crosses the graph in more than one point, it is not a function. So again, it's just going to be a yes-no question based on the rule. Okay? And so I'll reiterate that when we get to that kind of question. All right. So given this relation, 5, 4, 3, 0, negative 9, 7. I want to know from that, what is the domain, what is the range, and is it a function? So my domain is the set of x's. So the 5, the 3, and the negative 9. In no particular order. If you want to write them numerically, you can, but it doesn't have to be. The range are the y's. So 4 and 0 and negative 7. Anna?
Do you have to have like a...
Technically you should, because it's still a set of something. I probably wouldn't take off though. I don't know if other teachers would. But. And then I want to know, is this relation a function? So we look at the x's to determine that. Are all the x's different? Yes. Then yes, it's a function. So that is the question to ask yourself. If the answer to the question is yes, the answer to is it a function is yes. If the answer to the question is no, the answer to is it a function is no. Okay? So you might want to write that somewhere, because that's what you're going to ask yourself. Are all the x's different? And as you answer that question, that's the answer to the function question. So are all the x's different? Yes. And yes, it's a function. So you can see that that question is not too hard if you know the terminology. Okay? My next one. Given this relation, the domain is the set of all of my x's. So 2, negative 7, positive 3, and 2, which I'm not going to write again. And somebody's probably going to ask, if I wrote it twice, would you mark it wrong? I would not mark it wrong. I don't know if other teachers would mark that wrong or not, so I won't, but just so you know. The range The range is my set of y values. So from this relation, 10 and 1 and negative 6 and negative 8. Is it a function? Look at the x's. Are all the x's different? No. Then no, it's not a function. X's are repeating. It says x cannot repeat. That's what I highlighted up there in the notes. Okay, questions there? Okay, these are mapping diagrams. Very crudely drawn, but nonetheless, that's what they are. So, two things I want you to do. First, I want you to be able to read it. So you're going to write the ordered pairs associated with the mapping diagram. What ordered pairs does it give me? Okay? And then tell me whether or not, yes or no, it's a function. Okay? So it's as simple as following the arrows. Negative 4 is paired with 2. Five is paired with 2. 7 is paired with 3. And then I want to know, is it a function? Are all the x's different? Yes. Then yes, it's a function. So in my second one, my ordered pairs, 0, 9, 5 paired with negative 8, 3 paired with negative 8, and 3 paired with 11. So all you're doing is following the arrows to find out what x is paired with, writing those coordinates, and then determining if it's a function. Are all the x's different? No. No, so it's not a function. Okay, questions there with mapping diagram? Again, not really any work to do, but you got to know the terminology, okay? Here is where we're going to use the vertical line test. Now you can visually use the vertical line test, like just looking at it. I'm going to physically do the vertical line test, which you don't have to do, but I want you to understand really what it is. So, you're picturing vertical lines. Well, hopefully you know what vertical lines. Vertical lines are vertical lines that are the lines that go up and down, not left and right. Okay? So, can you draw a vertical line that passes through more than one point? And we need to do one to show you. That one vertical line that I just drew went through 2 points. That one vertical line, it only takes one. There's several. I mean, I could draw lots of vertical lines, you know, lots of, oops. That wasn't a very good vertical line, but I could draw lots of vertical lines. I only need one line to disprove. Oops. So that one vertical line went through 2 points. So that makes it not a function. So no, it's not a function. In my next example, again, you can visually do this process or you can physically draw the vertical lines, but I only need one to show you, even though there are several. That's not a function because when I drew the one vertical line, it hit 2 points on the graph. So not a function. Now, the last one looks very fragmented, but that's good. I just got this off my graphing calculator and then put it in a Word document here, okay? Because it's fragmented, what that's showing you is that it's going to just keep going out at the very slightest bit. It's never, ever, ever on either side, top or bottom. It's not going to go vertical, okay? It's not going to go vertical. It's going to keep going out slightly, out slightly. So when I draw a vertical line here, that's 1 point. Sorry, that's not a very good vertical line. I'll do it again. Vertical line, 1 point, 1 point. They're still not looking very vertical. I'm going crooked. 1 point, 1 point, 1 point. I'm only going to hit, any line that I draw is only going to hit 1 point. That makes it a function. Yes?
What if from the graph it's just a vertical line?
Then no.
No?
They hit every point then. Yeah. Okay, now if you think about the points, like this is about -1, 2, -1, -2. So what's happening? X is repeating. Okay, so 2 points or more? No. 1 point? Yes. So again, no work to do on that, but you have to know how to use the vertical line test. Because it's just a yes/no answer. So these go really quickly. All right, now we're going to talk about function notation. Do not let this kind of trick you in any way or be intimidating because it's actually pretty simple, okay?